Ever wondered how a crane lifts tons of steel high into the sky, seemingly with ease, or how such massive machines can be controlled so precisely by just a single operator? The answer lies in a remarkable technology that's all around us, yet often goes unnoticed. Or have you thought about how your car can come to a smooth, controlled stop with just a gentle push of your foot on the brake pedal? It's not just mechanical parts at work. There's something more powerful and subtle happening beneath the surface. The answer is hydraulics, a technology that uses pressurized liquid to transfer and multiply force. By harnessing the unique properties of fluids, hydraulics allows us to move, lift, and control objects far heavier than we could ever manage with muscle alone. This invisible force powers the machines that build our world, from the towering cranes that shape city skylines, to the landing gear of airplanes that touch down smoothly after every flight, to the heavy equipment that carves out the foundations of our skyscrapers. But hydraulics isn't just about brute strength, it's about precision too. In modern factories, hydraulic systems enable robotic arms to perform delicate tasks, assembling tiny components with accuracy that rivals the human hand. The same system that can crush a car into a compact block of metal can also assemble delicate electronics, showing just how versatile and adaptable hydraulic power can be. The secret behind this power? Liquids are nearly incompressible. Unlike gases, they don't shrink under pressure, which means they can transmit force efficiently and consistently. When you put them under pressure, they push back equally in all directions, allowing for smooth, controlled movement and the ability to amplify small inputs into massive outputs. Engineers use this property to transmit and amplify force through sealed pipes and cylinders, designing systems that are both powerful and reliable, capable of operating in the harshest environments. That's why a small input, like moving a lever or pressing a pedal, can create a massive output, lifting tons of earth with an excavator or raising the heavy bed of a dump truck with ease. Hydraulics is a story of human ingenuity, blending basic physics with cutting-edge technology. Today's machines use sensors and computers to control hydraulic systems with incredible precision, making them smarter and more efficient than ever before. And it all started with a simple law of pressure, discovered centuries ago by a brilliant mind, Blaise Pascal. His insights laid the foundation for a revolution in engineering and industry. From ancient experiments to the heart of today's most advanced machines, hydraulics has changed the way we build, move, and shape our world. Let's dive deeper into how this powerful principle continues to drive innovation and progress. Subscribe, like, and share Cosmo Academia. To truly understand the origins of hydraulics, we must journey back in time to the bustling streets and grand architecture of 17th century France, a period alive with scientific discovery and intellectual curiosity. Here we encounter Blaise Pascal, a remarkable mind whose contributions spanned mathematics, physics, and invention. Pascal was not just a thinker, he was a relentless experimenter, always seeking to unravel the mysteries of the natural world. Fascinated by the behavior of fluids, Pascal conducted a series of ingenious experiments. He was particularly intrigued by how invisible forces, like atmospheric pressure, could have such powerful effects on matter. Using a mercury barometer, Pascal confirmed that it was the weight of the air above us that supports a column of mercury. This was a revolutionary idea at the time, challenging centuries-old beliefs about the nature of air and vacuum. To prove his theory, Pascal famously sent his brother-in-law up a mountain, barometer in hand, to measure how air pressure changed with altitude. The results were clear. The higher you went, the lower the pressure. From these experiments, Pascal developed a key insight, now known as Pascal's law. He realized that when pressure is applied to a confined fluid, it is transmitted undiminished in all directions throughout the fluid. To illustrate this, Pascal devised the famous barrel experiment. He imagined a sealed wooden barrel with a long, narrow tube inserted into it. By pouring just a small amount of water into the tube, the pressure at the bottom of the barrel increased dramatically, enough to burst the barrel apart. This simple demonstration showed how a small force, when applied over a distance, could be multiplied many times over. This principle became the foundation for the hydraulic press, a device that uses confined fluids to multiply force, making it possible to lift heavy objects or shape metal with ease. While Pascal himself never built a hydraulic press, his law made such inventions possible, sparking a revolution in engineering and industry that would change the world. Today, the legacy of Pascal's insight is everywhere. From the construction equipment that shapes our cities to the machines that power our factories, hydraulics are at the heart of modern technology. It's a powerful reminder that sometimes the most profound revolutions begin with a single clear idea and the courage to explore the unknown. So what is Pascal's law? It's a fundamental principle in physics that explains how fluids behave when they're under pressure. This law is the key to understanding how we can use liquids to do incredible things, like lifting cars or operating heavy machinery with just a gentle push. When you apply pressure to a confined fluid, that pressure doesn't just stay in one spot. It spreads out equally in all directions throughout the entire fluid. No matter where you press, every part of the fluid feels the same amount of pressure. Imagine a water-filled bag. If you squeeze one side, you'll notice the whole bag tightens up, not just the spot you're pressing. That's a perfect example of pressure being transmitted equally through a fluid, just like Pascal described. Pressure, in simple terms, is the amount of force applied over a certain area. The formula is straightforward. Pressure equals force divided by area. This relationship is at the heart of how hydraulic systems work. If you keep the force the same, but make the area smaller, the pressure increases. That's why a sharp knife cuts better than a dull one. The force is concentrated on a tiny area, creating more pressure. In hydraulics, this principle allows us to multiply force. By adjusting the size of the areas where pressure is applied, we can make a small input force create a much larger output force. Picture two pistons connected by a tube and filled with oil. One piston is small and the other is much larger. This setup is the foundation of many hydraulic machines. When you push down on the small piston, the pressure you create travels instantly through the oil to the large piston. The oil doesn't compress, so the pressure is transferred perfectly. If the large piston's area is 10 times bigger than the small one, the force it produces will also be 10 times greater. This is how a small effort can result in a huge lifting force. That's the secret behind hydraulic lifts, using a small push to raise something massive like a car or a heavy piece of equipment with ease. This simple yet powerful principle is what powers car jacks, excavators, airplane brakes, and countless other machines that make our lives easier and safer every day. Pascal's law truly is the magic behind the strength of hydraulics, turning small actions into mighty results all around us. Let's see how a real hydraulic system works. It starts with an engine or motor driving a hydraulic pump, which pressurizes special oil. Control valves direct this high-pressure fluid to where it's needed. When an operator moves a lever, a valve opens, sending oil through hoses to an actuator. The actuator, usually a hydraulic cylinder, converts fluid pressure into mechanical motion. The piston inside the cylinder moves, lifting or pushing with amplified force. After doing its job, the oil returns to the reservoir, cools, and is filtered for reuse. This closed-loop system allows for smooth, continuous operation. That's how a small input from the operator results in a mighty lift or push. Hydraulics turns simple movements into powerful actions. Subscribe, like, and share Cosmo Academia. Every hydraulic system relies on a few essential parts working in harmony. The hydraulic fluid is the lifeblood, specially formulated to resist heat, lubricate, and prevent corrosion. The pump, driven by an engine or motor, creates fluid flow and pressure. The reservoir stores, cools, and filters the fluid. Pipes and hoses, strong and flexible, carry the fluid under high pressure to where it's needed. Control valves act as the system's brain, directing flow and controlling speed, direction, and force. Actuators, cylinders for linear motion or motors for rotation, convert fluid pressure into mechanical work. Each component is crucial for power, precision, and reliability. Together, they form a system capable of incredible feats. That's the elegant design behind hydraulic technology. Once you know what to look for, you'll spot hydraulics everywhere. Construction sites are full of hydraulic power. Cranes, excavators, bulldozers, and dump trucks all rely on it. In factories, hydraulic presses shape metal, and car lifts raise vehicles with ease. Wind turbines use hydraulics to adjust blade angles for optimal performance. Even theaters and amusement parks use hydraulic systems for smooth, safe motion. At home and in cars, hydraulics make life easier. Power steering and brakes are prime examples. Pressing your brake pedal activates a hydraulic system that safely stops your car. Hydraulics deliver high power in compact spaces, making them ideal for countless applications. From heavy industry to daily life, fluid power is everywhere. It's the hidden force that keeps our world moving. Early hydraulic systems were purely mechanical, but today's are much smarter. Modern hydraulics use electronic sensors and controllers, creating electro-hydraulic systems. Pressure sensors monitor fluid pressure, ensuring safe, precise operation. In a hydraulic press, sensors guarantee the right force is applied every time. Temperature sensors protect the system by preventing overheating and fluid breakdown. If things get too hot, the system can cool down or shut off automatically. Position and speed sensors track actuators, enabling pinpoint accuracy and repeatable movements. Robotic arms on assembly lines rely on this feedback for flawless performance. Sensors transform hydraulics from blunt tools into high-precision instruments. The result: smarter, safer, and more reliable machines. Electronics and hydraulics together are a powerful combination. Subscribe, like, and share Cosmo Academia. Why choose hydraulics over gears or electric motors? The answer is power, precision, and flexibility. Hydraulic systems have an incredible power-to-weight ratio. A small cylinder can lift huge loads. Their nearly incompressible fluid means instant, smooth response with no jerkiness. With electronic controls, hydraulics achieve pinpoint accuracy in speed and position. The fluid also acts as a coolant, letting systems run hard for long periods without overheating. Flexible hoses allow creative machine designs, unlike rigid mechanical linkages. The power unit can be placed far from the working parts, making layouts efficient. This flexibility and reliability make hydraulics the top choice for demanding applications. It's why they're everywhere, from aircraft to industrial robots. From Pascal's 17th century insight to today's smart machines, hydraulics have shaped our world. The simple idea of using fluid to transmit and multiply force lets us build, move, and create on a massive scale. Hydraulics combine raw power, precise control, and flexible design. With a lever or button, humans command forces that lift tons or shape steel. As technology evolves, hydraulics are getting smarter, integrating sensors, AI, and eco-friendly fluids. Self-monitoring systems now predict maintenance and optimize performance. Fluid power remains a cornerstone of engineering and innovation. Next time you see a machine at work or press your car's brakes, remember the journey of that force. Hydraulics is a testament to human ingenuity, harnessing nature's laws to build a better future. It's the quiet, fluid force that moves our world. Subscribe, like, and share Cosmo Academia.